So we're doing number patterns. So topics to today. We're going to do homework review, modular arithmetic, clocks and time, Pascal's triangle, Fibonacci sequence, and triangular numbers if we have time. So I will do homework review. Problem 1 was how many factors does 433,210,603,900 have? So in the chat, please type your answers. Okay, so I'm seeing a lot of your answers. So first what we had to do was factor out. So we have to factor out 433,210,603,900, right? So to do that, we factor out the most obvious factors, which are 2 squared and 5 squared, which are 100. And then we factor out 17, then 19, and then 37 squared, and then 101 and 97. And then we add 1 to each of the exponents and multiply them together. And we get 3 times 3 times 2 times 2 times 3 times 2 times 2, which is 432 factors. Most people did not have trouble with this, and if they had trouble, they left it in the wrong answer format, like they only did prime factorization. Okay, homework problem 2. What is the product of the factors of 213,444? In the chat, please type your answers. Okay, so yes, the answer was 462 to the power of 81. So first what we had to do was find the number of factors. And to do that, we needed to find the prime factorization of 213,444. So we find the prime factorization, and then we find that there, when adding 1 and multiplying the exponents together, we find that there are 81 factors. And then we find that the product of the factors is the square root of 213,444 to the power of 81. And we can see that 213,444 is the square of 462, so we can simplify this to 462 to the power of 81. Problem 3. How many of the factors of 578,877,975 are squared? So in the chat, again, please type your answers. Okay, so first we need to factor out the number, right? So we get the prime factorization, and then we see that the number of square factors would be how many 2's fit into each of the exponents. So for 3 to the power of 2 and 5 to the power of 2, we would have that number to the power of 0 and that number to the power of 2. That also applies with 17 to the power of 3. And then for 7 to the power of 5, 7 to the power of 0, 7 to the power of 2, and 7 to the power of 4 fit in that. That's why there are 3. So we multiply 2 by 2 by 3 by 2, and then we get 24 factors are squares. Fourth problem, how many factors of 182,432,325 are multiples of 5? So again, in the chat, please type your answers. Okay, so the prime factorization of this number is 3 times 5 squared times 107 times 127 times 179. So that means that when we're trying to find the numbers, the multiples of 5, we add 1 to each of the exponents, except for the exponent of 5. So we get 1 plus 1 times 2 times 1 plus 1 times 1 plus 1 times 1 plus 1, and that is equal to 32. So 32 factors of this number are multiples of 5. And then how many factors of 58,320,000 are perfect squares or cubes? So in the chat, please type your answers. And a lot of people miss this problem. Much of the time you didn't show work, so I don't actually know why, but yeah. So, okay, so let's find the prime factorization first. So we find that it's 5 to the power 4 times 2 to the power 7 times 3 to the power 6. So we have to find how many factors are perfect squares. So three multiples of 2, including 0, fit into 5 to the power 4. Four multiples of 2 that are powers fit into 2 to the power 7, and 3 to the power 6. So we multiply 3 times 4 times 4 to get 48 factors are perfect squares. And then we have to find out how many factors are perfect cubes. So we find how many 3's go into each of the exponents, including 0, right? Including the power of 0. So we have 2, 3, and 3. So that multiplies out to become 18. So we add them together and get 66. But we have counted the powers of 6's twice because we count them in both the squares and the cubes. So we need to subtract how many powers of 6 there are. So we have to find out how many powers of 6 there are, and we find that it's 1 times 2 times 2, which is 4. And then we subtract 4 from 66, and we get 62 factors, or perfect squares or cubes. So that is the end of the homework review. So in the chat or unmute, say if you have any questions. And if you do not have questions in the chat, please type that you do not have any questions. So, okay. So many people are saying that they do not have any questions. So we will continue.
All right, so we're going to be talking about modular arithmetic now. So modular arithmetic is basically, it's pertaining to remainders, and it's called a mod function. So instead of saying modulus, you just say mod. And the entire concept is pertaining to remainders and divisors and stuff like that. So so in the notation A mod B, it would be A is the dividend and B is the divisor. So it's A divided by, so like one example would be 13 mod 2. And so, yeah, you just read it out as 13 mod 2. And so 13 mod 2, the value of that is just the remainder of 13 divided by 2. So 13 mod 2 would equal 1.
Yeah.
Oh, sorry.
Okay. Yeah. Okay, so it would be 1 since the remainder is 1 when dividing it by 2.
Yeah, so that's just the
and
residue.
that 1 would be, yeah.
All right, so on the next slide, we're going to be talking about other number patterns found using other modular arithmetic. So in each of these numbers, I want you to type in the chat about what you notice about the units digits. So we have 2, 4, 8, 16, 32, and the rest of the 12 pattern of the 12 powers of 2. So in the chat, type in what you noticed about the units digit for all of these numbers. All right, so I'm getting some answers. So yeah, the correct answer is there's a pattern, right? So we can see it's 2, 4, 8, 16. So the units digit are 2, 4, 8, 6, right? And then we have 32, 64, 128, 256. So then the units digit again, it's 2, 4, 8, 6. So now we need to notice how this corresponds with patterns of 2, 2. So since we have a cycle of 4, we can use that to our advantage. So let's suppose there's a question asking, so this is a good example. So let's suppose there's a question asking on the AMC about what's the last digit of 2 to the 897, or what's the remainder when 2 to the 897 is divided by 4. So since there's cycles of 4, we can simply use this. So 879 mod 4, and we're doing mod 4 because there's a cycle of 4. It's going to equal 3. So there's a remainder of 3. And the third number in our cycle of 4 equals 8. So we can use the repetition of 4, and we can use mod 4 to solve for the last digits of higher powers. Does everybody understand how we got 8 and why this is important?
And just a thing to remember, when you're putting a number like a to the power of b, when you're finding like the nth digit, it will always follow a pattern. This pattern can be 10 digits long or 2 digits long, but it will always be a pattern. So that's what you should be looking for whenever you have like find the nth number of like the nth digit, like the 10th digit, 1st digit, 100th digit of x to the power of y.
Yeah, there's the AMC was asking questions about like find the 100th digit of 1/7 is a good one. So 1/7, which has a cycle when you write it out as a decimal, has a cycle of like 6 or 7 digits. So you can use mod in that sense too. So it's not only exponents, you can use it for finding the nth digit after the decimal of some fraction,
Right. So this just circles the thing.
All right, so here we have an example. So find the units digit of 9 to the 31. So of course it would be quite a headache to solve it out. So try to find a pattern and use modular arithmetic and find the remainder and plug that remainder into the cycle and see what you get. All right, so we have like 2 answers so far. So we're gonna wait until a couple more roll in. Okay, so first we have to find a pattern. So 9 to the 1 equals 9, 9 squared equals 81, 9 cubed equals 729. So we have alternating digits of 9, 1, 9, 1, 9, 1, and so on. So if we have an odd exponent, then it's going to end with a 9. And if you have an even exponent, it's going to end with a 1. So since 31 is an odd exponent, that means it has to end with a 9. It's easy to get 1 just because when you're finding remainders, and if you do like a remainder of 2, you don't do the number after the second part of the cycle. You do exactly the second number in the cycle. So the second number in the cycle. So in this case, it's going to be the first, but you don't want to do the number after the turn you're trying to find the cycle. All right, next question.
Okay. So when you find a pattern for the nth digit of the number, you will see that they always will follow a pattern. All
right, so type each of your answers in the chat and label 1, 2, and 3. And then put your answers as you go. So don't put them all at once. Put them as you go. So after you solve 1, just put number 1 I got,
right.
whatever you got.
Yeah.
Also, when you're solving these, keep in mind that you can't take 5-6 minutes to do these questions. The AMC has a time limit, so you need to be cautious of how much time you're taking and how fast you're doing your arithmetic. Right now, you do have a little bit of flexibility when it comes to time, but as you move further into problem solving, you need to get faster and faster. Okay, so we're getting some answers for number 1. Okay, so we got 4 or 5 answers for number 1, so you should be wrapping that up. Okay, so we've also gotten 3 or 4 answers for number 2. So we have some students moving on to 3. That's good. Okay, so after we get 3 or 4 minute answers for number 3, we will go over these 3 questions. Okay, so we've gotten 4 or 5, number 3. So we're gonna move on to the explanations. Okay, so this is correct. So no matter what power you raise to 6, the units digit is always 6. So 6, 36, 216, 1296, and so on. The unit digit is always 6. So that's a handy thing to know. As you solve more and more of these questions, you'll also be able to just memorize some of these cycles. Like when you solve more, you don't have to like sit down and memorize them and try to memorize them, but as you solve them, you'll start to realize you'll memorize the cycles for 7 and for 3 and for 9 and 6. So find the unit digit of 7 to the 401. So the cycle for 7, I believe, is 7931. And so when we do 404 mod 4, we get a remainder of 1. And the first number in the cycle 7931 is 7. So the unit digit will be 7. All right, moving on to the third question. So the third question is find the tens digit of 7 to the 401. So now instead of finding the pattern for the unit digit, we're finding the pattern for the 10th digit. So that's 0440.
Wouldn't the pattern also be 044?
Yeah, it could also be 044. Yeah.
So then if you do 044, then you would get 4.
Well,
pattern
no.
0440 because that itself repeats. If it were 044, then it goes 044044044, but it goes 04400440. So the pattern is not 044.
Okay.
Yeah. So now we just do the same thing as we did in number 2. So since 401 is one more than a multiple of 10, the 10th digit will be 0. Yeah, so be careful about the wording. Yeah.
Also, just something. So for number 2, Rishab misspoke. He meant 401, not 404. Yeah.
Oh, sorry. Yeah, I meant 401. My bad.
Okay. So now we will be seeing number patterns with factorials. So what do you notice about the last digit of these factorials? Just type it in the chat. Yeah. Okay. Yeah. They end in 0 after 5 factorial. So since all factorials greater than 4 factorial have their last digit as 0, and this is not a coincidence. The only way you can have 0 as your last digit is if you have 10 as one of your factors. Starting from 5 factorial, every factorial will have 5 and 2 as at least one of their factors, so they will always end in at least 1 0. And we can actually predict how many zeros a factorial will end with just by looking at their prime factorization. So the number of 10s in a factorial will be determined by how many 2s and 5s are in the prime factorization. But since there are way more 2s than 5s, we can just focus on the 5s when calculating the number of 10s that factor into the number. So for example...
wait, sorry to disturb it, interrupt Shani, but the reason why we're focusing on the 5s is no matter how many 5s we count, there will always be 2s to multiply with the 5. If we just count 2s, then we're going to have more 2s than we have 5s. So we're going to have leftovers 2, so we can't rely off of the number of 2s. If we just count 5s, then regardless, we're going to have, lots of 2s to pair with the 5s to make 10.
Yeah, each 5 has a 2 to pair with, but not each 2 has a 5 to pair with. So, yeah.
Is that because the 2s come before the 5s?
It's because you get a factor of 2 every second number or every other number, while you get a factor of 5 every 5th number. So naturally,
yeah. So if we take 100, for example, we have more 5s. No, we have more 2s in 100 than we have 5s in 100, right?
And by 100, he means like less than any number less than 100. Right, so there would be more 2s less than 100 than there would be 5s less than 100, and this goes for any number, any positive integer. So okay, so back to the example. So let's expand 11 factorial. So it's just 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is 2 to the power of 8 multiplied by 3 to the power of 4 multiplied by 5 squared times 7 times 11. So how many 5s does 11 factorial have in its prime factorization? Just type it in the chat. Yeah, there are 2 5s in the prime factorization of 11 factorial. So 11 factorial will end with 2 zeros. So you can see this for yourself. 11 factorial is it's 39,916,800. So that ends in 2 zeros, as we can see. So 11 factorial ends with 2 zeros. So what about 26 factorials? How many zeros does it end in? So in the chat, you can just type your answer.
And instead of just finding the prime factorization, just count the number of 5s. Like, forget about 1, 2, 3, 4, forget about 6, just count the number of 5s, so you only need to worry about 5, 10, 15, and so on.
Yeah. So I'm not seeing any answers. You just need to say how many zeros it ends in, not what it multiplies out to. Okay, so I'm seeing a lot of answers. Some of them are incorrect. Okay. So I've gotten 5 answers, so I will continue. So at first glance, you would think that since 26 divided by 5 would have 5 in it, would round down to 5, the answer would be 5, but no, this is not the case. 25 is equal to 5 squared, so there's actually another 5 which we missed because we only divided by 5. So there are actually 6 whole 5s in 26 factorial. That means it ends in 6 zeros. So what should we do to find out how many zeros x factorial ends in? So we should find x divided by 5 rounded down to an integer plus x divided by 5 squared rounded down to an integer plus x divided by 5 cubed rounded down to an integer until one of the values, and so on until one of the values rounds down to 0. And then we just stop counting them. So our strategy, so let's generalize this for what so let's generalize what we found. If we want to find how many times a prime number appears, a prime number a appears in the prime factorization of x squared, we should find x divided by a rounded down to an integer plus x divided by a squared rounded down to an integer plus x divided by a cubed rounded down to an integer all the way until one of the values rounds down to 0.
We're not including numbers like 2x and 3x just because that would be overcounting. So in the previous example, we're not going to include numbers like 20 and 15 just because then we're just going to count an extra number of 5s. And you know, a lot of questions you have to be careful of overcounting. So that's going to result in overlaps.
Why would you be not count 20 and 15?
No, what he means by not counting them is we do not count them when we count the extra 5s. So when we're finding like the 5 squared, or we would only use powers, like numbers that have 5 squared in their prime factorization, and not just 5 in their prime factorization. Otherwise, we will be overcounting in that case. So yeah. Okay. So this lets us.
So for the last problem, you said it was 6, but there's only going to be 5 squared and 5 to the power of 1.
We count 5, then we count 5 squared, and then we count how many 5 cubes are in a factorial, are in the number of the factorial, so that we can see how many zeros there are. You do not want to overcount by counting.
Yeah, so we did 26 divided by 5, which was 5. Oh, well, it's more than 5, but like it rounds down to 5. And then we did 26 divided by 5 squared, which rounds down to 1. So then we did 1 plus 5, which is 6. So whatever, you know, the second part of this slide is what you want to focus on. X divided by a plus x divided by a squared plus x divided by a cubed.
Could you go back? I'm still could you go back and explain it again?
Yeah. Okay. So what this so basically what Rashad meant was when we're counting how many 5s we did not count, we do not want to count the 5s that we already counted. So we wouldn't do x divided by 5 plus x divided by 5, like right, because that would be counting the things we've already counted. So we would want to do x divided by 5 squared because we haven't counted that second 5 in the multiples of 5 squared. We want to do x divided by 5 cubed because we haven't counted that third power of 5 in multiples of 5 cubed. So what he meant to say was we are not repeatedly counting the numbers we have counted when doing this. The numbers we have already counted when doing this. Does that explain? Does that help clarify?
Yeah, but wait, so you divide the entire number by 5, and then you divide 25, and you divide the entire number by 5 squared until you get to 0?
You don't divide 26 factorial by 5 squared. You divide the 26 by 5 squared.
Yes,
that's what you. Okay, yeah. And that's just
so
because
you do an increasing power until you're left with 0.
Right. And the reason we do not divide 26 factorial itself is because we're going to be overcounting by a lot if we do that. Because if we wanted to divide 26 factorial, we would just see, like if we wanted to work with 26 factorial, we would divide by as many 5s go into it. But because it's just the consecutive numbers multiplied together, we are working with those and not the actual final result of 26 factorial. So yeah, that's why we don't work with 26 factorial, but the how it multiplies out, like each of the numbers below and equal to 26. Okay. So
yeah, so this is the part you want to focus on, the second part on that slide. This part.
Yeah.
The we should. Yeah. That's what you want to focus on.
Yeah, you can take a screenshot if you'd like. So you can keep it in mind. These slides will also be shared with you. So yeah, but just make a note of it in your mind so that you remember. So for the practice problems, okay, so how many zeros do the following factorials end in? Then find the number of 2's in the prime factorization of 17 factorial, and then find the number of 3's in the prime factorization of 57 factorial. You have 10 minutes to do this. And if you are stuck on any of the problems, in the chat, type, like you can private message either me or Rashad if you don't feel comfortable saying it in the general chat, but please tell us if you do not understand how to solve something. And then also, if you want, there are some slides that we have not gone over, that we will not go over in class, that are part of this presentation, that talk about how to find how many of a composite number goes into x factorial. So you can look at those after class. We will not be explaining it in class today because it takes some time to explain. However, the slides do explain it. So yeah.
Yeah, we would present, but there's a time constraint, so we'll just send it out to you. So if you like, you can go over it in your own time.
Yeah. And if you have any questions about those slides, you can feel free to like email us at Mathema official email, or you can in the Google Classroom, you can like private comment on one of the assignments, like the homework assignment, and say, can you, like, I am having trouble understanding this part, and then we will try to help. So I'm not seeing very many answers. So make sure that when you're solving this, you are, for each of the problems, like send your answers in the chat as you do them, so that we know that you're working, that you are actually doing the problems and not just like waiting for us to solve them for you. Because these problems help you understand if you do know how to do something or if you don't. And if you don't, that will help us know how to help you. So yeah. And remember that it's not saying 17, but 17 factorial. These are all factorials. And basically what a factorial is it's every number until the number given multiplied together. So 5 factorial would be 5 times 4 times 3 times 2 times 1. So
instead of doing 17, finding the prime factorization, you're doing 17 by 2 and seeing how many 2's are in 17. So 2, 4, like that.
Yeah. You are seeing how many numbers less than or equal to 17 have a 2 in them in their prime factorization. So yeah. Okay, and then note that for like, if you're getting big numbers, then you are probably doing it right, because there are very many numbers that have, there are very many powers of 5 that fit into the first few numbers. So yeah.
have a question. So would you count, say, for like 150 factorial, or no, I mean 125 factorial? Would you count 5 to the power of 3 too?
Yeah, you would.
Okay.
Because it's every number until 125 inclusive multiplied.
Yeah, so you would count it as 1. So 125 divided by 5 cubed. So that would just add 1 0.
Okay, so I'm seeing lots of answers for 1, 2, and 3. So you should be close to done for 1, 2, and 3. And you should be getting started on 4 and 5. And again, if you aren't if you're still on the first 3, that's okay. It helps to pace yourself, but only pace yourself after you've learned the concept and fully understand it. So yeah.
I have a question. So for the last one, 57 is divisible by 3. So do I just,
Yeah.
so is 3 like the only thing, or do I have to keep going until the biggest prime factorization I can find goes into 57?
You have to go until the biggest power of 3. You have to go until the biggest.
Okay, thank you.
Primes.
Only left to it.
Yeah, sorry.
Did you crash?
Yeah. Okay. Hopefully that doesn't happen again. Okay. So I can't see I can't see the chat from before I crashed. So I don't know if
We have
anyone.
one answer for number 5.
Okay.
I don't know if we got any private messages, but yeah, we got one answer. So we'll wait for one or two more to roll, and then move on.
I'm just waiting for one more answer to number 5, and then we will go again.
Are there any people that are still stumped on one question, or if they're still on the first one? They need help.
Okay, someone gave me the answer for number 5, so we will go over the answers. So how many zeros do the following factorials end in? So 3,200, we use the strategy we found earlier, and we do 3,200 divided by 5, then add that to 3,200 divided by 25, and add that to 3,200 divided by 125, all the way up to 3,125, and we get 640 plus 128 plus 25 plus 5 plus 1, which is 794. And remember, you round down each term. You can't just add the terms together and then round, because sometimes those decimals can add up to a whole number or to greater than a number. And if you round down, you're going to get the wrong answer. Like if you round down after you add, you're going to get the wrong answer. So make sure to round down after you find each term. So then number 2, 130 factorial. We use the strategy again. We do 130 divided by 5 plus 130 divided by 25 plus 130 divided by 125, and we get 26 plus 5 plus 1, and that's 32 after rounding down each term.
Okay, so before she moves on, I saw some people put some other answers in the chat, and that's fine. I just wanted to know, like, what did you do with that? Like, where did you go wrong? So just put in the chat if you got something else, like, what you did wrong.
Yeah. Okay, so someone just asked if we round down the answer of 130 over 5. And so on. So we round down each individual term, not after adding. If you round down after adding, you will get the wrong answer, or you can get the wrong answer. You might not always get the wrong answer, but most of the time you will. So yeah. Okay.
Stop dividing.
You know when to stop dividing when whatever you're dividing by rounds down to 0. That's when you stop doing it. Because if it rounds down to 0, that means that no power of x that is that great or greater will fit into that factorial. So
for the second one, we get until 125. If we move on to the next power, if we do 130 divided by 625, it's gonna round down to 0. So you're like nothing's gonna happen. You're not gonna add anything to 32.
Right. So it's even if you continue
every single time. So there's no point in it.
Yeah.
So you keep doing it until the next power of the number is greater than the number?
Yeah. If it's equal, then that's fine. But if it's greater, then you want to stop.
Because then it won't fit in that number. Okay. So it appears that many people just forgot to add the 5. So make sure to check your work after you do it, just to make sure you don't get something wrong because of a mistake like that. So number 3, 31 factorial, we just do 31 divided by 5 plus 31 divided by 25. And since 125 is greater than 31, we do not go beyond 25. So we do 6 plus 1 and we get 7. So yeah. Then find the number of 2's in the prime factorization of 17 factorial. So we do 17 divided by 2 plus 17 divided by 2 squared, which is 4, plus 17 divided by 2 cubed, which is 8, plus 17 divided by 2 to the power 4, which is 16. So we get 8 plus 4 plus 2 plus 1, which is 15. So that means after rounding down each term, so that means that we get 15 2's are in the prime factorization of 17 factorial. Then for the last question, find the number of 3's in the prime factorization of 57 factorial. So we do 57 divided by 3 plus 57 divided by 3 squared plus 57 divided by 3 cubed, which is equal to 19 plus 6 plus 2, which is equal to 27 after rounding down each term. So the number of 3's in the prime factorization of 57 factorial is 27. So looking back at the chat, from what I remember seeing, a lot of people did get it wrong. So yeah, make sure that if you got something wrong and it wasn't due to a silly mistake, in the chat, please please type why you got it wrong, just so we know that why, and so we can help you if there's anything that needs to be helped with. Okay, what answer did you get for number 1? Anand.
And explain how you got it.
Yeah.
Okay, so how did you get that answer?
So, okay.
Well, first and foremost, you want to see that's more than our original number. So even though it's not like a written rule, that means it's probably wrong. You know, like if it's 3200 factorial and you're getting 3,919 zeros,
make sure
logically,
that the only I don't think any of the numbers, like the only potential that it has to be greater is if you were doing 2's, but like even then it would be equal pretty much to the number. So yeah, so you should never be getting above the number, but you should be getting a big number for like big numbers. So you might have added 3,200 to whatever you got, and that might have been what caused you to go wrong. Remember, do not divide 3,200 or any number by the prime
as long
to the
as
power
you make
0.
sure whatever's on the screen, like whatever we put there, you know, as long as you understand that that is right and that's what you should do,
yeah,
it's fine.
Right.
What's the best way of finding the prime factorization? Because anytime I do it for big numbers, I always just get it wrong. I get close, but I always just get it wrong.
So you should not be finding the prime factorization for like factorials when you're doing them, like for big factorials. But for big numbers, like 8-digit numbers or something, look for the most obvious primes. So like if it ends in 2, divide by 2. If it or if it ends in an even number, divide by 2. If it ends in a 0, divide by 5. If it ends in a 5, divide by 5. If it ends in like, or if the digits add up to 3, divide by 3. If the digit, or a multiple of 3, divide by 3. If the digits sum to a multiple of 9, divide by 9. And yeah, just take the most obvious primes first, and then you will get a smaller number, and then you will, it'll be easier for you to find the prime factorization of that.
So pretty much just know your divisibility rules. And also I suggest just doing more practice, because as you do more practice, you'll notice more patterns and you'll be able to realize which numbers are divisible by, let's say, 7 or stuff like that.
Okay. If there's a bigger, like, if there's like 3 different ways to divide a single number, should I divide by the biggest or the smallest number?
The smallest.
Yeah, divide by the smallest first, because it's very easy to think that a big number divides a number, and like you could potentially be wrong. But if you divide by a smaller number, you will be going down like incrementally, and there's like less room for mistakes because yeah.
And also I remember there was a question like Monday or something, and it was one of the primes that it was divisible by was like, I think it was 83. And you know, of course you're not going to look at a number and the first thing that you're going to divide, you're not going to divide it by 83 just because, you know, it's one, it's harder to divide by, it's not obvious, you're not going to figure it out.
Right. So divide by
we're not expecting you to divide by 83. Divide it by all the other numbers like 2 and 3 and 5, and then that's going to lead up to you getting 83 as the last leftover number. And then you recognize 83 as prime. So
yeah. Okay. So now
we're gonna do clocks and time. So this might seem very trivial, but they ask a lot of questions about, you know, angles and times, clocks and stuff like that. So of course you should know this like the back of your hand. 1 day is 24 hours, 1 hour is 60 minutes and 3600 seconds, and then 1 minute is 60 seconds. So you need to know this very well, of course. So you also want to know like the angles. So in 1 hour, you cover 30 degrees. So between 12 and 1, or between 1 and 2, that's because it's a circle and it's divided into 12 increments. So 360 divided by 30 is just 12. So each hour is 30 degrees on the clock. And then each minute is 6 degrees on the minute arm, 0.5 degrees on the hour arm. It's not often that they're going to ask you about the minute difference on the hour arm. You're just gonna, it's mainly good to know that 6 degrees are on a minute arm,
right,
and 30 degrees on the hour arm.
Usually they won't specifically ask you for the degrees on the hour arm. However, many questions can still apply it. Like if they're asking for the degree between the hour and minute arm, you can't just do, oh, at 1 o'clock, it's going to be like 30 degrees from 12, right? You're like, if it's 1:30, you're going to do like 45 degrees for, it's going to be 45 degrees from 12. Like it doesn't just like automatically go from 1 to 2 every hour. It slowly goes there. So you're going to need to know it, but like it won't specifically be asked.
Okay, so also 1 second is 6 degrees on the second hand, and 0.1 degrees on the minute hand, and 1/600 degrees on the hour hand. Those last two, they're going to be very seldomly asked. Most questions are pertaining to hour and minute. They may still be useful for some questions, like rarely asked, but
and these are things that like you don't need to memorize. If you know that there are 360 degrees in a circle and there are 60 seconds in the whole revolution, then that means that you just do 360 divided by 60 and you get the 6 degrees on the second hand. Like
don't memorize it, or else you're going to forget after a month and you're going to mix them up. Just know why they're true so that you can prove it later on.
Right. So like just remember that 360 degrees is a whole circle, and you should be, and just remember like your units of time, and you will be able to remember the degrees by just dividing that 360 degrees by that units of time.
Okay,
So-
so here are some practice questions. So make sure to enter your answer in the chat, or you can private message me or Shani. How far in degrees will the hour hand travel in 12 hours? How far will the minute hand travel in 2 minutes? And how far will the hour hand travel in 2 minutes? So enter your enter as like degrees. You don't have to do like the degrees sign, just do whatever in degrees.
Yeah, and we'll give you 5 minutes to do these problems. Again, if you have any questions while solving these problems, please feel free to unmute and ask, or type your question in the chat.
Also, Anand, remember that a clock has 12 increments, not 24. So just keep in mind of that. Okay, so I'm getting I've gotten 2 answers so far. 3. Getting some answers for number 2. You should be able to do these pretty fast. If you can't do it right now, that's fine, but you have to do
Eventually,
questions fast.
Eventually, you should get to a point where you should be able to do the questions quickly. However, if that point is not during our course, but like you do it later on, that's good so long as you get there.
And the only way to get faster is to do practice. So, I sent out tests the other day, so do that when you're done with the course. Try to get faster. There's also lots of online resources. You can look up a lot. Google is very useful. If anybody of you guys are familiar with countdown round and math counts, stuff like that helps build up your speed. Trying to time yourself and doing it quickly.
I've gotten at least 6 answers for number 3. So
yeah, we've gotten plenty of answers for 1 and 2. So we're just waiting for some answers. So I've gotten 3 or 4 answers for number 3. Okay, so I think we can explain them now.
yeah. So okay. So how far in degrees will the hour hand travel in 12 hours? So 12 hours is the whole revolution thing, because there are only 12 hours on a clock. So this would be 360. Then how far will the minute hand travel in 2 minutes? There are 60 minutes in an hour. So that's 1/30 of 360 degrees, right? 2 over 60 is 1 over 30. So 1/30 times 360 would be 1/30 times 360 would be 12. So the minute hand would travel 12 degrees in 2 minutes. Then how far will the hour hand travel in 2 minutes? Remember, there are so this would be 1/30 of an hour. So 1/30 of an hour, and an hour, remember, is 30 degrees. So that would mean that it would travel 1 degree in 2 minutes. So yeah. If you guys have any questions about these, remember, ask. And
if you know how a clock works.
Right, just like in your mind, visualize a clock. And if you can't do that, like on a paper, it's just easy to like quickly draw a clock. It doesn't have to be perfect, but just being able to remember how it looks can help you a lot when you're like trying to logic your way through a question.
Yeah, know how it works as well.
Yeah. Okay. So 360 degrees, 12 degrees, and 1 degree. So
here's some harder questions. So
yeah. So this is another problem. How long will it take the hour hand to travel 45 degrees? In the chat, please type your answers.
Okay, so we've gotten at least 4 answers. That was good. That was actually quite fast. So that's what you should target for.
Right. But again, if you can't do it quickly at the moment, that's okay. So long as you are getting better, you know, progress is progress. You will be able to do it in time. So yeah.
All right, so we're gonna go over the solution for this. Yeah, you have to use proportions for this. So 1 minute over 0.5 degrees will equal how many minutes over 45 degrees? So 45 divided by 0.5 is 90. So then we're just going to do 90 times 1. So it's going to be 90 minutes for the hour hand to travel 45 degrees.
Just a thing to note, when you're doing like proportions and you have like units on the top and the same units on the bottom, they cancel out. So like you will not have degrees anywhere in your final answer because you have degrees in both the numerator and denominator of your proportion. So yeah. And your units that aren't the units of your answer should always cancel out when you're setting up a proportion. Otherwise, you are not getting the right answer. So, yeah. Number 5, how long will it take the hour hand to travel 75 degrees?
So you want to set up a proportion just like we did last question?
Yeah. Okay, and many people keep giving like decimal or fractional hours. You would not express hours in normal conversation as decimal or fraction. Like you would say like 50 minutes or 20 minutes. You wouldn't like say 1.75 minutes, so, or 1.75 hours. So please put it in minutes format or hours in minutes format.
Usually the question, like, since we're talking about the AMC here, and even in other math competitions, they will give you either, you know, express your answer in the form of minutes, or the options will be in minutes,
Hours.
or sometimes they'll even do it in hours. Seldom, but they will do it sometimes. But they'll say in the question, express your answer as a common fraction in hours or something like that.
Right. The only place where you would normally like express your answer as a fraction is if you're doing like a fraction of a second, like that's where you would use it. But normally they're going to do it in like hours, minutes, and seconds, where you do not express a fraction, but
Okay,
rather
so
just whole number.
I've seen 6 answers, and I don't know, like it's like
I've seen 3 private message, so.
Yeah, so I've gotten some private messages too. So 150 minutes is the correct answer. So good job, most of you guys got it right. So we're gonna do the same thing as we did in the last question. So 1 minute over 0.5 degrees equals how many minutes over 75 degrees? So then we can just, you know, do 1 times 75 divided by 0.5, and we get the answer of 2 hours and 30 minutes, or 150 minutes. So good job.
Yeah.
Okay, we're going to do some more hard questions, because this is what helps you learn the most.
So the question is, at 12 a.m., so midnight, the angle between the hour hand and the minute hand is 0 degrees. How long will it take for the hour and minute hands to create a 33-degree angle? So remember that it's both the hour and minute hand. So you're going to need to know how much it moves, how much each of the arms move in a minute, or in however long you're doing, right? So
you're
yeah.
going to see more questions like these on the NC.
Right.
You're not going to see questions like the original 1, 2, and 3. You're going to see more questions like the harder ones.
And make sure when you're giving your answer, you round if there is any rounding, or make sure you simplify it. For example, if I was going to give, like, if the answer were 2 over 4, I would give the answer as 1 over 2. Usually when you're doing like a math competition, it will give all, like if you're doing AMC, it will give the answers as simplified format. However, if you're doing other competitions where you need to write out the actual answer, they will count it as wrong if the answer is not simplified. So, and make sure you know the units that you are expressing your answer in. So for example, so if you do not know the units that your answer is in, look at the proportions you set up to figure out your answer, and the degrees should or the units should cancel out and give you the final unit you're expressing it in.
Yeah, this question is definitely a bit challenging.
Yeah.
So, whatever answer you get, you want to use some logic to make sure it makes sense,
Right.
A
So
lot
if
of these AMC's questions, you can use logic to, eliminate so many possibilities. A lot of option choices will throw you off, so you want to make sure have good problem solving techniques and good test taking techniques as well.
Right. A lot of people are giving an answer of like 66 minutes, but like think about it. When you're like over an hour, when you're going an hour, the arms already cross, right? They are going to form a certain degree measure, right? Already. So it should be less than an hour. Like it'll create two kinds of each angle. So for example, like 10 degrees, you'll be able to make that twice when you go like in 1.5 hours. So your answer should probably be much less than an hour, unless it's like, how long does it take for it to be 180 degrees? So yeah, like just
Yeah, so for whoever put 66, that may be right, I'm not sure. But that's probably like the second or third time that it makes a 33-degree angle. We're looking for the first time it makes a 33-degree angle. So
right. And if you think about it, when you're looking at a clock, like, if it's like 12:01 a.m., that degree measure is going to be like less than 33 degrees, right? It's going to be like 5.5, I think, right? So you are going to so each so like it will have to be greater, like it will have to be 33 degrees very soon after 12:01 a.m. So your answer should be like, within like maybe like a quarter of an hour, and like again, like just use logic. When you're at like 1:15 a.m., right? The degree the angles make is like slightly less than 90 degrees. So that means that it has to be before 12:15 a.m. So yeah. Use logic when looking at your answers, and if it does not follow logic, it's probably wrong. Okay, so I've seen at least 1, 2, 3 correct answers. So yeah. So I will explain the question. So this is a little difficult because both the hour and minute hands are moving at the same time. So after each minute passes, the hour hand moves 0.5 degrees and the minute hand moves 6 degrees. So that means that there's a 5.5 degree change every minute. So after m minutes, it's 5.5 m. After m minutes, it's 5.5 m angle degrees between each of the hands, right? So we can set up an equation. 5.5 m is equal to 33. So we divide both sides by 5.5 and we get m is equal to 6. So that means that it's 6 minutes. And we know that it's 6 minutes because when we set up our equation, we had m in terms of minutes. So at the very beginning, I got someone saying the right answer, but they had the wrong units. So make sure you know the units you're supposed to be using.
I didn't put 6 minutes, but then I thought about it, but then I got confused because I thought if I do 6 times 5, I did 6 times 5 instead of 6 times 6 to check my answer, so I got confused.
Mm-hmm. So everyone in the chat, because I only got 3 people get it correct, and many of them after doing it multiple times, but I got very many 66s, like private messaged and stuff. So in the chat, tell us why you got it wrong. Like, what did you do that made you get it wrong? And if there's anything like that we need to address, then we will address it. So please
remember to pay attention. We're looking for the first time that like even if it doesn't say like when's the first time, that's what it means. That's always what it's gonna mean. So unless it specifies otherwise. So
Right.
I think
It
you
will
did
always
both,
be
she said,
referring.
so.
Yeah. It will always be referring to the first occurrence. So yeah. Okay, so some people said that they got it wrong because they forgot that that they have to include both the hands when doing it. And then someone else checked it incorrectly.
Like, I'm not very good at making equations and stuff. So something I would do is, in this situation, you get like if this is like a math counts question, then there's a different story. But this is AMC, so you're getting answer choices. So instead of solving for an equation, you can literally just plug in the answer choices, solve for each answer choice, and see what you get.
Right, but
Use the answer choices to your advantage. It's good to know how to solve the problem, but when you're in the test, they don't care how you solve it. They just care that you get the right answer.
If you think about it, like say if there's 4 options and 2 of them are odd, you know it can't be odd because that would mean 5.5 times an odd number equaling a 0.5. Just check the other 2.
yeah.
That's correct. Yeah, that's what you want to do when you're taking the test.
Again, like so if the question is very short, then it's fine to check the answers. However, if the question, like when you're plugging in the answers, like if it takes a long time to actually check the work by using the answers, then you should probably just go along with solving the question like how you normally would. So yeah. Okay. So right now we're going to have a break. So okay, so AMC problems. So what is the measure of the acute angle formed by the hands of the clock at 4:20 p.m.? So the answer choices, so hands of the clock usually refer to hour and minute hands. So like they always refer to hour and minute hands unless otherwise specified. So you guys have 3 minutes to solve this, and if you need more time, that's okay. So yeah.
While you guys are solving this, I'll just say, oh, I already have some answers rolling in, but I'll just say some more about what we talked about in AMCA versus Math Kangaroo. I would highly suggest spending more time on preparing for the AMCA than Math Kangaroo, just because it's much more recognized.
Prestigious. Yeah.
It's like 300,000 students take the AMC. So if you get an above average score, or if you get a good score, it's much
and and on top of that, you should probably prepare more for math counts than AMC, although their topics really overlap a lot, right? Because math counts, you can easily get a scholarship. Like if you're first at your chapter, if you go to, or if you win or something at state, like top 10 or top 4, like you can get a full ride scholarship. And if you go to nationals, like not only would you get to meet like someone famous, like the speaker is usually famous, but you can also like you can win lots of scholarships.
You'll get to meet Richard Ruzick.
Right.
If you don't know who that is, he's like the CEO of like AOPS.
Right, AOPS. Right, and then one year they had like an actor, I think.
So for middle school, math counts is definitely like the deal. The reason why AMC is just good to know about is because in high school, AMC is the deal.
Right.
In high school, there is no math counts. It's just AMC, and the stakes in AMC are way higher than they are in math counts.
And you'll find that in high school, they're a lot more like, not no name, but like they're a lot more like lesser known math competitions than in middle school, because there's like no math counts. There's no like main focus, like, thing like math counts. So then there are like a lot of other like no name kind of tests, which you can also do well in and get scholarships for, although there'd be less than like,
Yeah, the main thing in high school, there's a lot. There's Mandelbrot, there's ARMO, AMR. I think it's ARMO.
It's like Rocket City or RCMO.
There's a lot, but no, it's ARMO.
For what?
No, like high school, it's ARMO, right?
I don't know.
ARLM.
I thought you were talking about RCML. But
No, I was talking about ARML. Yeah, there's Mandelbrot AMC. There's definitely much more variety, but still, I would still say AMC is still the heavy hitter. Like, you know,
Right. Like everyone's gonna know AMC if they're talking about math for a math competition in high school, but for other things, they are like not gonna know it as well, and that makes like winning in it have less weight, like in something that not many people know of.
getting first in AMC definitely has like 50 times more weight than getting first in Math Kangaroo. Like, I will say that, like, you know, and like, I think I took Math Kangaroo in like 4th grade, you know, like it doesn't really, so, you know.
Okay, so back to the question. So I've gotten a lot of answers. So the answer is D. And how we get this is 420 would have the hour hand at 130 degrees. So 4 1/3 or 13/3 multiplied by 30 degrees would be 130 degrees. And then the minute hand would be at 120 degrees, right? So that would mean that 130 minus 120 is equal to 10 degrees. So then the answer is D. Wait, does anyone have any questions about this? Okay, some people keep getting like kicked out. I'm hoping that's not like caused by me. But if you're getting kicked out, sorry, I guess. Okay, and if no one has any questions about the previous problem, then this next problem is what is the remainder when 1,999 is divided by 2,000 or when 19,099 to the power of 2,000 is divided by 5. So remember, use like the patterns, like we talked about patterns, modular arithmetic. There's going to be a pattern, you know, when you're doing mod 5. And yeah. And okay, so when you're looking at this problem, when you're looking at it, you might think you're going to have to do 1,999, like the whole thing divided by 5, like to the power of each number divided by 5. However, when you do it, you only need to care about the last digit because like the tens place, hundreds, and thousands place are all divisible by 5. So that like those parts will always be 0, right, when it's mod 5. But then for the 9 part, that's what changes. So that's what changes the modulus, the modular residue. So yeah. So I've gotten one answer so far. So I still only have one answer. So if you are solving this, that's okay. But if you do have an answer, make sure to send it to either me or Sean.
I mean, I narrowed it down to 2 numbers, but I can't get it more than those 2 numbers.
Okay, so remember it always follows a pattern. So if that pattern is like 4 digits, then you're going to have like if that pattern repeats every 4 digits, then find the modulus of 4, like 2,000 mod 4, and then that will be which number whose modulus by 5 you look at. And also, when you're doing AMC, you will not be able to say, I know it's one of 2 answers. You either get it right or you don't. So
I don't know if this is true I don't think it's true for AMC 8. But in AMC 10, they give you the awful choice between guessing and leaving it blank, because you lose points
For every wrong answer.
you lose points for every wrong answer, but you gain points for leaving it blank. But you
get
gain
one-
less
yeah.
points than however
would
many
if
you
you
gain
got
for
it right.
correct answers.
Right. You get 6
Why do you
points.
gain points when you leave it blank?
Okay,
Because
that's why they give you, okay, I'll explain. That's why they give you that awful choice. Okay, so let's suppose you're between A and B, okay? So if you choose, let's suppose A is the correct answer, and you're guessing between these two answers and you put B, okay? And if you put B, you don't get any points, okay? If you put nothing, you get 1.5 points, but if you put A, you get 6 points. So now you're trying to decide, okay, should I not risk it and get an easy 1.5 points, or should I risk it and have a possibility of getting 6 points?
And if you leave it blank and like you're either waiting for like the results or you realize that you like got lower than the cutoff, you're gonna be like you know, mentally like, why did I do this? If you left it blank.
It's very, very annoying. It is very annoying, you know?
Yeah.
Because
Fun fact, I guessed on one problem, got it wrong, and I missed the cutoff for AIME by 0.5 points. So
yeah,
that was fun.
it is very, very annoying.
Right.
Good to know.
So yeah, whenever
That's
you're
not the case in AMC 8 though. AMC 8, they don't really
yeah, you
punish
either
you
get
guys
0
like
or
that.
1 point. So
But in AMC 10 and 12, they really, really want to, you know, make you mad just because.
they want to see if you actually know the question.
They want to see how confident you are, you know?
So how many
Right.
questions are there?
25.
So if you just don't do the test, you could do better than someone who actually tried in the test.
I mean, you're gonna get like 40, or like you're gonna
You're
get
gonna
like
get what, like
37.5 points.
37.5, yeah, right?
And that's like the cutoff is in the hundreds.
The
So like,
cutoff is usually like 110 or one.
Right.
I think this year is like 104.
it was 103.5.
Yeah.
Okay, so I'm just
You would have to get like 15 correct and then leave the rest blank. I think.
so if
I don't
you do
suggest that though,
you
because
do the last 5 blank because you said those are the hardest, and
Mhm.
then you do 15 that you know for sure. If you don't do anything, then you could just get it right. Just get
yeah,
it.
but the thing is, like, the AMCs are getting harder. So you know,
Yeah, they're getting
what they did last year is they took like the last 5 questions and they put it in like 15 through 20, so that it would like mess you up. They would like play with you, you know?
right.
And so if you look at like number 16 versus number 25 was significantly easier.
And also, like, you have to keep in mind that, like, you might allot too much time to a question and not get to 15 questions or something. And then, like, you would, like, either be stuck between guessing, or you would not guess and you would not make the, you know, cutoff.
Yeah, it definitely requires much more thinking than math counts when it comes to what you should answer, what you shouldn't answer, what you should guess on, what you shouldn't guess on, how much time
Yeah,
you should
it's
spend on
like
the question.
much more psychological when you're doing it.
It's horrible. It's like the test makers were like their lab rats.
Yeah,
Yeah.
no, they really don't want you to do good. And that's how it is for any test, honestly.
They don't want you to guess, and like I get that, but like as someone who takes the test, it's not fun. So, okay.
Like any non-official like thing that's not made by the government, like to not be challenging, it just they want you to fail.
Yeah.
Prep or something like that. They do those so that you don't really fail this test if you're doing good or not. But for anything else, they just want you to fail.
Mhm. Okay. Yeah. So back to the question. So the answer was B, and I think that most people, I think only one person or 2 people got it wrong, but then they changed their answers. So yeah. So the answer was B. So 1999 ends in 9. And then when you square that, it ends in 1. And then this repeats 9191. So if the power is odd, it ends in 9, but if it's even, it ends in 1. So then 2000 is even, so the number has to end in 1, so the answer is B. And also, so the number ends in 1. So if the number ended in 9, then you would do 9 mod 5, and you would have gotten 4 as your answer. But like it did not. So make sure you weren't looking for like an answer that does not exist when you're doing the test.
So you'd have to do 199 times 199 3 times.
You wouldn't actually have to do 199. You wouldn't have to do 1999 multiplied by itself 3 times, because when you do like 1990 is divisible by 5. So no matter what power it's raised to, that part will always be like that part modulus 5 mod 5 will always be 0. So you just have to care about that 9 at the end, because 9 to the power of x mod 5 will be changing, and that will be what changes 1999 to the power of 2000 mod 5, you know?
Oh, so good. Like for the last one could just be multiplying the ones digits.
Yeah.
Okay.
Yeah. Okay, so the next problem, what is the 10th digit of 7 to the power of 2011? So the answer choices you have are 0, 1, 3, 4, and 7. So I do not remember what the correct answer for this question is, but usually the correct answer will have a number very close to it if it is right. This is not always the case, but it happens a lot of the time. So yeah. Okay, I've gotten one answer. So yeah. Remember, everything follows a pattern. Everything follows a pattern, so you should be looking for a pattern. So when you're looking at the 10th digit, I think we had a previous problem where we were looking at 7 to the power of x, and we were looking at the 10th digit. So if you remember what the 10th digit is, then you'll be able to solve this really quickly.
You need to be able to reflect off of previous problems and remember what you
Have learned.
realized, you know?
Yeah.
That's why practice is so important. But like, it's not just practice, it's good practice.
Yeah, if you're just doing tests and not looking at the tests, then it's really pointless, because you're just like, it's more of like an ego boost than anything if you're not
And I
going
mean,
to be checking.
the solutions are like well written. They're not bad solutions.
Right, you can,
and the best part is they give you multiple solutions for each problem.
for most problems.
For most problems that, you know, you can, so especially like geometry ones, you can learn several techniques to do one problem, and you can apply what you learned on like one question and you can use on another test, because there's only so many things they can ask about. They just ask it in different ways, you know?
Right.
And that's the most important thing to realize.
Like you can know some complex formula that can just be like boiled down to the Pythagorean theorem, and like you might only need the Pythagorean theorem to solve like 4 of the questions, right? And that would be really helpful for much.
The AMC 8 does not require a lot of knowledge. You essentially just need up to 8th grade knowledge, maybe 7th grade. It just requires how well you can apply that knowledge.
Yeah, AMCs are not hard really because of the content, but because of the way that content is
unless
asked.
You're talking like 10 and 12, you need to know some more stuff for 10 and 12.
Right, but when you're actually like at that grade level, like 10th or 12th grade, it'll be very like not easy, but the content itself is easy-ish. So yeah. Okay, so what is the 10th digit of 7 to the power of 2011? I saw like at least 5, 6 answers. So the answer was D. So as we had found earlier, the pattern was 04404, or sorry, 0440 0440, right? And when you get like the last X digits repeat, that means that that whole pattern is going to repeat all over again. So because you can see 7 to the power of 1 and 7 to the power of 5 and then 0, 7, that means that that pattern up till 7 to the power of 4 will repeat over and over again. So using the numbers above, we can see the pattern is 0440, and we can do 2011 mod 4, which is equal to 3. And 7 to the power of 3 has a tens digit of 4, so the answer is D. So we shall be doing, does anyone have any questions about that? If not, we can do this. Okay, so we are going to be doing a Jamboard. Let me just share it with you guys. So everyone will be able to edit it. So please be appropriate, be on task. Don't go off topic when you're on it. So use sticky notes to show your answers. And if you have a question, message us in the chat or unmute so we can answer it for you.
You can also enter a text box for your answer. It's up to you.
Right, but it just, yeah. Oh, can you not move anything on the first slide, please? Yeah, okay. Please do not move anything on the first slide.
Yeah, just answer the questions. That's all you need to do.
Yeah. Yeah, and do not erase anything because it's important to the question, and again, please do not move anything on the first slide. Just go to the problems. Yeah. Okay, so everyone.
Wait, never mind, continue.
Everyone should be on the problems right now. Again, yeah. So
there's 14 people on the Jamboard, so I'm expecting minimum 10 answers on each question. That's what I want.
There should be 17 people on the Jamboard right now because there are 20 people in this call, including us. I don't know if anyone has joined multiple times due to audio issues or stuff, but you still should have more people on the Jamboard. Okay, so 506 mod 7. I'm getting lots of answers of 2. And so when you do 506, when you do 506 mod 7, you get, so you divide it by 7 and find the remainder. So 506 divided by 7 is equal to 72, and then you have a remainder of 2. So the answer is 2. Okay, so number 2, what is the tens digit of 7 to the power of 456? We saw multiple times previously that the pattern is 0440. So we should do 456 mod 4, and we should 456 mod 4 is equal to 0, right? So that would mean, 456 mod 4, 56, so we divided by 4, we get 100, we get 114, and then remainder 0. So it would be 0440. So we'd take the first of those, we would take the last of those because mod 0 mod, so 0 mod 4, when you get when you get x mod 4 is equal to 0, you would take the last digit because that would just be equal to that 4 itself, right? 0 mod 4 is equal to 4 mod 4. So you'd get the 4th digit, so 7 to the power of 4 has a tens digit of 0, so the answer is 0. So I'm seeing a lot of answers of 4, and I don't know why. I don't know if I did my math wrong. Rashab, can you check?
Wait, sorry, what should I check?
Can you check to see for number 2 if the answer is 0? Because I'm seeing a lot of
number 2. 7 to 456. Okay, let me see.
And please make sure you're actually doing the problem and not just copying someone else's answer. I know it's very easy.
7 has a cycle of 4, right?
Yeah, it's 0440.
Okay, so
please make sure you're not copying other people's answers right now because it's very easy to. However, it's not going to help you in any way if you're just copying people. So yeah. Okay. And if you're stuck on a problem,
I think I got 0 too. Wait, let me make sure. Wait,
and
is
if
it fine if I can I write on the Jamboard? Like,
yeah,
because
yeah, you
most of the
can.
people put in their answers. Okay, so 0, 4, 4, 0. What's 456?
456 is a multiple of 4. So
Yeah, so then that's what, 114?
yeah, I think. Yeah. Yeah, it's 114.
Yeah, so if there's no remainder, it will just be.
So it would be the 4th digit. So it
Yeah,
would be
it's
0.
just,
So
okay, cool.
yeah, I don't know if like the people who got it wrong, to anyone who got it wrong, I don't know who you are because this is anonymous, but like, please make sure you know why you got it wrong, or like, you know how you got the answer, and therefore you know why you got it wrong. Please like go back and look at it. So the answer for
if the mod is 0, what do you do?
It's the fourth
you
one.
take, yeah, so if 0
First, the
mod
last
4
one of the
is,
cycle.
Okay.
yeah, it's the last, yeah, because like x mod, so 0 mod x would be equal to x mod x, so it would be the x number, so the last, yeah. So the answer, someone in the chat private messaged me asking what's the answer. I'm assuming that you're talking about number 2. The answer is 0. So yeah. How many zeros does 50 factorial end with? Use the strategy we found. 50 divided by 5 is 10. Then 50 divided by 25 is 2. Then 125 is greater than 50, so that doesn't matter. So we do 10 plus 2 and we get 12. So yes, everyone seems to have gotten it correct. So yay. Gold star. Okay, how many 2's are in the prime factorization of 124 factorial? You can use your calculator. So I've gotten 190. I'm gonna leave this problem because not very many people have answered it. I shall wait for like 7 more answers or 5 more answers for this problem. So yeah. And again, you can use your calculator. So like, yeah. Okay, so I will wait for people to answer this. Again, go at your own pace. But like, yeah. Go at your own pace, but like, make sure you aren't like still on the first question.
We're encouraging you to go fast because you're gonna need it.
Right, but like if you cannot go fast at this point in time, that is also okay. Just make sure you're on track to get there at some point, you know? Okay, so let's.
You can also see if someone duplicated it or if they actually made a new one by seeing where the sticky notes made. Like the new sticky notes made like left, then someone actually made that, and
We're not gonna do that much. We're just trusting that you did your own
Yeah.
answer.
This is here to help you guys, you all. So like if you're gonna be copying,
Like I
that's on you.
don't want this to sound bad, but you guys getting, 5 out of 8 versus 7 out of 8 doesn't really affect us.
Right, we're doing this to help you. If you are not gonna take advantage of that, if you're just gonna like try to get everything correct rather than actually understand, that is not on us, you know? So like please do your own work. And if you get it wrong, that's fine, so long as it was your, answer to begin with.
Yeah, I mean, you
So,
need to get questions wrong to get questions right.
yeah. Like, you learn from mistakes, right? So, yeah, which is kind of cheesy, but like, you do learn from mistakes, so you should.
Like my first
you know?
AMCA got like a 9. Okay, so
Yeah.
no, probably less. I probably got like a 2.
Many people get
I mean,
very
my
low
first math
scores
counts
when they
test, I
first
got a
get
3. So
yeah. I mean, I think I knew a lot of the content because like I just did.
I knew
But
nothing,
like, you know,
so that was great.
but like my average for like 6th grade was like in the 20s, right? For math counts.
I think mine
And
was like a 9 in 6th grade.
but
Like, I
here's
don't
the
know if you
thing.
remember, I was in last in 6th grade.
But here's the thing. The whole like test for math counts is worth 46 points. So like us getting like in the 20s, that was like getting a 30 for us was good, right? Like it was very good at the time.
Well,
but
yeah,
like
I never got a 30 though.
I mean,
I was in 6th grade, Shani. My highest score was like a 20.
right. Many people do not do like really well in their first like few years, like first 2 years
Yeah,
of math
like
count.
me, all like pretty much. I'm pretty sure Amy didn't even make math counts in 6th grade, right?
Right. And then she like got second in state. So like people, you will get
It
better.
makes a difference.
Yeah.
It makes a difference.
Like a lot
Like
of people.
I'll say 6th grade to 7th grade is the biggest jump. Like there will be a big difference between 6th and 7th.
I mean, yeah. And then 5th and 6th, you don't realize like what you're doing. So like there isn't much of a jump.
Yeah, you
Right.
don't know what you don't know what you're heading into. So
Yeah, you're
you
trying to
just
get
kinda,
acclimated to like you know, the competition
you're
itself.
learning. You're learning.
Right.
Yeah, I don't know if you remember, son. In 6th grade, I was down astronomical.
Yeah, a lot of people jumped like huge. Like it was like huge amount of points. Like, you know, like for example, like in like from 6th to 7th grade, I jumped 10 points. And from 7th to 8th grade, I jumped like 5 points, like on my
Yeah,
average.
like Amy went from not making math counts in 6th grade to getting like top 4 on the team in 7th grade. I went from being last on the team in 6th grade to like I think my average went up by from 9 to 31. Okay.
Oh God, that's like a lot, you know?
And then Gopal went from like 12 to like 31.
Right. Like, you know, it's
Everybody,
like
you make a big jump from 6th
you
to
will
7th.
at the time you will not realize how much you've improved until you take the test and you're constantly getting like 40s or something, or like, you know, 30s.
Well,
from
no,
like,
I don't think constantly getting 40s is a very realistic example.
right, but like constantly getting a score which you thought like once upon a time was like very good, like if that's like your baseline now, then like you're gonna realize you've improved, but it doesn't feel like you've improved.
Yeah,
right?
all the people that have made nationals and done well in math counts, they weren't like that since 6th grade, except for one person. But
Who?
Luke.
Oh, yeah.
They weren't like that for all the time. They were also very, very garbagey in 6th grade.
Right, you're gonna be like garbage at one point, you know, you're gonna have to be garbage at one point to like become.
Except unless you're Luke.
Right, there's some people who are just like
there are some that like very few. I only know one.
Right.
Or two.
Jonah?
No. You know Karthik Chetty? Him.
No, I don't.
Oh, okay.
Okay, I don't think we should like divulge people's names.
Oh yeah, that would be not good.
Yeah. Okay. So anyways, I see 7 answers on this. So like I'm gonna explain it. So you do 124 divided by 2, right? And you get let me just type this because 124 divided by 2 is equal to 62. Then 124 divided by 4 is equal to 31. 124 divided by 8 is equal to 15 when rounded down. 124 divided by 16 is 7 rounded down. 124 divided by 32 is 3 rounded down. Then 124 divided by 64 rounded down would be 1, right? So that would be equal to 119. And so most of you guys got it correct. For the person who got 93, you can feel free to private message me about why you got that, because like we'd just like to know so we can help clarify anything if necessary, you know, and yeah. So Okay, so find the units digit of 3 raised to the 788 power. So 3 to the power of 788. Well, there are only, well, okay, there were 7 answers earlier, so 8 shouldn't be too bad. Right, so 788, or 3 follows the pattern of 3, 9, 7, 1, right? It repeats every 4. So that would mean that 788 mod 4, we have to find that, right? That would be equal to 0, right? So when it's 0, you use the last, you use the last digit, right? And that would be 1. So yeah, you guys got these correct. Good job. Most of you got it correct. For the person who got 9, you probably just accidentally found the wrong answer for the mod, which is okay, but like know what you did wrong and how you can fix it. Since like you aren't really showing your work on this, you're only putting your answer. We do not know how you're getting that answer. So only you have access to your work and only you will know how you got it wrong. So it's your responsibility to either ask us questions or tell us or figure out what you did wrong. You know?
Wait, can you just give me like a quick debriefing of like mods, because I came late to class because of my internet, so I think that's when you explained it.
Oh, okay. So mod is basically the remainder. So A mod B is basically the remainder when you divide when you divide A by B. So 788 mod 4 would be the remainder when you divide 788 by 4, right? But because 788 is a multiple of 4, that mod would be 0. So modulus is just remainder. And yeah, that's pretty much everything. Yeah.
Thanks.
No problem. Okay. So the hour hand and minute hand create a 90-degree angle. How many minutes will pass for the hour and minute hand to make a 100-degree angle? Okay. Okay, so you're gonna need to round for this. So there are only 5 answers. I'll just wait for one more and then start explaining it. And yeah. Also, it's 11:23, so class will be over pretty soon. So we will not have had time to go over the rest of what was planned for today. But basically, it was the Fibonacci sequence, Pascal's triangle, and triangular numbers. You can feel free to look at that after class because like they're really helpful. What the content that is covered. However, like it takes maybe like 15 minutes to cover. So it shouldn't take you too long. If you have any questions about that, feel free to ask us. The homework will be based off of some of that. So you're going to need to like know what's on those slides. Also, it's only 11:24. Do not leave class early. Class ends at 11:30. So yeah. Okay, so there are still only 5 answers for this problem. Make sure that you are putting your answer on this, on the Jamboard. Yeah. And okay, so there are 6 answers, so I will start explaining. Oh. Okay, so for this, so it's currently at a 90-degree angle. So that means we want the minute hand to travel 20 more degrees, right? So 20 degree, and it asks for minutes. So when you leave it in seconds, that is wrong. So basically we want it to increase by 20 more degrees, right? And we have to do 20 divided by 5.5 because the angle measure between the hands is increasing by 5.5 every minute. So 20 divided by 5.5 is 1.818, I think. It's around that. So that rounds to 1.8. So the people who put 1.8 minutes, you are correct. And yeah. make sure you're looking at the units you need to answer in. Otherwise, you will get it like wrong, you know? So, yeah. Okay, so this is the second last problem, I believe. Okay. Okay, so I will wait until 11:28, and then I'll explain these problems, and then in the chat I'll just give you the link for the homework. I can give you guys the link for the homework right now. And again, here are the slides for triangular numbers, Fibonacci sequences, and Pascal's triangle. So, yeah. Wait. Okay, in the chat, I'm going to type the, I'm going to give you guys the link for the homework if it's going to load the chat for me. Okay, so it's 1:27. So, yeah. Also, please do not add extra slides to this presentation, to this Jamboard, please. Okay, so at 3 in the afternoon, the hour hand and minute hand create a 90-degree angle. How many minutes will pass for the hour and minute hand to make a 100-degree angle? Round to the nearest tenth of a minute. Okay. So basically, so currently it creates a 90-degree angle. And you want it to increase by 10 degrees, right? So we do 10 over 5.5, right? So how many minutes will pass for the hour and minute hand to create a, oh wait, no, sorry. So the hour and minute hand are currently at, they're currently at 90 degrees. However, the minute hand is before the hour hand. So it's going to constantly reduce until they overlap. So we have to figure out how many more minutes will it take for them to overlap, like how many minutes will it take for the hands to overlap. And then we have to figure out from there how many minutes will it take for it to become a 100-degree angle. So what we're going to do is so we know it's 90 degrees right now. So we do 190 degrees, or it's 90 degrees right now, and we know we want to get it to 100. So we do 190 over 5.5. And the answer that you should get is 34.5454. So 34.5. So 34.5 is correct. Yeah.
Oh, I did what you were about to do, which is like, yeah.
Yeah, that's okay if like you made a mistake. Like all of us make mistakes, you know. But like make sure you catch it while you're doing it, rather than like after you finish, like, you know. So yeah. So it is 12 o'clock. So the hour and minute hands are at a 0-degree angle. How many minutes before the hour hand and minute hand will cross again? So basically what we have to do is we have to figure out, so it's going to be in the next hour, right? It's going to be after the next hour, right? Because after this goes around, it's going to be 1 o'clock, and the hour hand will be at 12, and the minute hand will be at 12, and the hour hand will be at 1, right? So that will mean that they haven't overlapped yet. So it has to be sometime after 1. So we know automatically it has to be greater than 60 minutes. So at 60 minutes, it's at it's at 30 degrees, right? So we would do 30 divided, so we'd do 30, so we'd have 30 degrees, and then we'd have to divide it by 5.5 and add it to 60 degrees, right? And 30 divided by 5.5 is equal to 5.45. So basically, when you add 60 to 30 over 5.5, you get 65.5 if you round it to the nearest decimal. However, if you did not round it to the nearest decimal and you just rounded it to the nearest number, then 65 would be the correct answer. So good job to everyone who got this right. So yeah. Okay, so class is technically over. In the chat, I will type the, so here's the link to the homework. What do you mean, how is the decimal? And the last question, you do 30 divided by 5.5 because at 1 o'clock, it creates a 30-degree angle. So you do 30 divided by 5.5 to figure out how many minutes from 1 o'clock it would take for it to, overlap after 1. And yes, this will be posted in the Google Classroom. So yeah, feel free to leave. Bye.